Okay folks, my heat pump, the fan quit spinning on it, so of course the AC is not going to work properly. So I got some tools and I'm going to have a meter, and I bought a new capacitor for it. Now I've already shorted this one out. You can hear the rooster, he's crying for treats. So this is actually dual capacitor. So what you need to know is that it'll be marked. One will be neutral, it'll have a little dot right here. The one will say fan, and then one will say herm, and herm is for hermetically sealed. That's for your compressor. The other one's to kickstart your fan. Without this, your fan's not going to start. Now these caps go out about once every 5 years, so just keep that in mind. But this is also very dangerous to do, so if you don't know what you're doing with electricity, don't do this and get a qualified technician out to pop a new cap in. Another thing is you want to check your blower motor, make sure it's all clean. There's no bad wires on your system, and on your furnace. And so when you do check on that, make sure there's nothing bad. I always clean out my my blower fan, like at least once a year, because you can get a lot of stuff in there, and that can also cause problems, especially with the airflow. And it could be the reason why your stuff's not working. But I know that anybody want a rooster? It's kind of spoiled. Anyways, here's the first thing we do on this system. Right here, you're going to locate, after you turn off all the power to all this stuff, you're going to locate the fuse box thing. Oh, come on. It's kind of there. And you're going to pull this fuse right here out. Okay? And you're going to inspect that. Make sure this fuse is in good shape. It don't look too good to me, but yeah, I guess it'll do. So just remember the way you pulled it out. I don't think it really makes a difference. It's just a straight up fuse. I got to put my cheaters on because I'm old. So yeah, it's marked on both sides. So that doesn't really matter. So that can go up there. Now you want to follow the line from your fuse all the way up here, and you'll find out that this little panel right here is where you need to go. So we're going to go ahead and open this up. It's usually just one little screw. And you're going to pull this panel out. Now I'll repeat, do not try to do this with the power on. I know some people do, especially technicians when they're in a big hurry, but you don't want to do that. And also on the inside, there'll be diagrams here of what the circuit's like and what it's supposed to be doing. There's a relay board, which is relay board's about right here, okay? There's a couple of relays, you see them in there? Now the first thing you want to do when you look at this is look at what wires are what. So if we pull it out, well, first of all, before we do that at all, we want to identify which one is the negative. And so this is the ground part of it. You'll notice that this one's like this. Measure the voltage first to make sure there isn't 470 volts attached to this capacitor. So I'm going to get the DC voltmeter, set it up here so I can see it good, and I'm going to touch the positive on one side and the negative. I want to get it real good in there so I know I got no voltage. Now I've had this off for about, I don't know, I shut it off in winter time because I just decided I don't need the heat. It's just costing me a bunch of money. So this says that there's no voltage on this cap anymore. So I hope that's true. In fact, I'm going to go check this meter, make sure it's accurately reading, and then I'll be right back. So I did verify that my meter is reading correctly. So get yourself some gloves, just to help to isolate yourself and against any shock. Get some nice rubber gloves. These are little shock gloves, but I guess they're better than nothing. And so we're going to pull this cap out and we're going to replace it with the new one. So the first thing I'm going to do though is I'm going to get a really long screwdriver that's insulated on the tip. And I'm going to touch the positive and negative to see if I get any spark. I'll do this the same way over here. If I get in there with it. Yeah, there's no spark. So this capacitor is fully discharged. So what we're going to do is we're going to pull it off. It's going to be a little hard to get in there. Let me get this thing fixed out of the way. And there's a band that holds it on. Screw somewhere. See if I can even see the dang thing. Okay, so I got the little stubby here, and I'm going to kind of fill around for that. Screw, this is going to be a real bitch put in the back. I don't know why they designed it this way. I could put it on the other side. Hope I didn't lose it. Oh, it's in there. Okay. Just going to pull that back a little bit so I can get to this capacitor and leave much of a lead run on this thing at all. Okay. So, first thing I'm going to do is same like a car battery. This is voltage DC. It's up to 440 to 470 volts DC. So folks, be very careful on insulated pliers when you detach anything from the system. Come on. There we go. Okay, so we can get a better look at this now. Be careful if they're not insulated. You probably should use your own little thing. Probably should use one of these things, little pliers to pull these things off with, because they're insulated and you don't want to take any chances. This is the fan side, this is the hermetically sealed for the compressor, and this is the frickin' ground. Okay, sorry about that. If you're trying to follow live on this one, don't listen to this first part. So there's no insulation on that, so guess what? That came off of the, let's double check. That's for the compressor. So that goes on the herm side. It's HERM. And I'm going to use insulated connectors for this. Because this is not insulated on this connector. And like I said, you don't want to get shocked with 440 to 470 volts DC. It'll kill you. It probably just make me giggle. I've been shocked so many times, but that's what it is. And it shouldn't make a difference what side you put these other two wires on, but you can see that goes to a little transformer over here. It's a little transformer assembly. And it looks like that one wants to be, let's just take a look here. I wish these wires are longer. This is just ridiculous. Too short. And so we're going to put the red one on now. Let's make sure we don't get bit. Okay. So I'll leave that one hanging now. See, I got a nice long wire there. That's nice. How's the rest of them though? That's just ridiculous. And just so I don't make any mistakes, I'm just going to go ahead and make sure they look the same. Before you place the capacitor, folks, make sure you look at this part of it where it says it's a dual capacitor, so one side's 55 microfarads and the other side's 5 microfarads. And you can pretty much guess which one's for the fan, which one's for the compressor. Look here, it's 55 microfarads and 5 microfarads. Do not screw this up. If you put the wrong capacitor on there, you could blow out your compressor and other shit. It can really cause havoc. So I'll put that on now. Make sure you get these connections on here good. Real good. They shake off while this thing's vibrating. You're going to have to come out and redo this. And then you've already energized the circuit again. And guess what? You're going to be redoing the process, but this time you might have a fully charged capacitor you have to discharge. So we're just going to flip that in. Okay. So we're going to hold this up, put some blocks in there. So it's got something to sit on. And that'll make it easier. You have to try to get this thing in. Much easier. Come on, I know. I found it. Oh, you're going the wrong way. Thank you, God. Struggling to have to do this. I'll get her in there. Nice and tight. Take the blocks out now. Okay, that'll hold her. So, next step to do, folks, well, we already did. We'll reinsert the fuse into the block. And then we're going to go energize the system. And we're going to see if the fan turns. While I'm doing that, I'm going to go ahead and reposition the camera so you can see the fan and see if it starts up when I start everything up. There you go, folks. Fan's running. Basically, it's working throughout the house again. Thanks for watching. Thumbs up, like. I hope you got good information off of this. And be safe. You're going to do something right. So I'm going to stress again. This is not the only fix for an air conditioning unit, for like a heat pump. But generally the caps do fail within 5 years and you have to replace them. If you don't feel confident enough about doing this yourself and being safe enough to do it, I suggest you get a professional out there to fix it for you, even though it's going to cost you hundreds of dollars to put in a $20, $30 capacitor. But follow the steps. First thing you want to do is you want to shut all power off. And you want to inspect your blower and your furnace. You want to inspect the wiring. You want to make sure there's nothing blown. There is a capacitor inside your furnace also that runs that blower motor that pushes the air throughout your centralized heat in your house or AC. Number 2, make sure you're very careful and disconnect all the power. Pull that fuse and then check for the voltages across the capacitor. And always treat it like it's charged, even if it doesn't say, even if it says 0, don't trust it. Verify. You're not really supposed to use a screwdriver to short the two sides of that dual capacitor. You're supposed to use a resistor, and they teach you that in school. I know my brother took HVAC, and so I kind of learned it with him, even though I didn't go to HVAC school. Kind of went to a different other school like engineering. But make sure you short that out and use a long insulated screwdriver. Then still treat it like it's fully charged on that capacitor. And make sure you use isolation. Make sure you have good rubber soled shoes on, isolate you from the ground. Make sure you have isolated whatever you're going to use, needle nose pliers, just regular pliers. Make sure you're insulated also. And then carefully read what's on there. And you're supposed to pull the negative wire off first, which is the ground wire, just like a car battery, and then you can pull the positives. And you saw how I replaced it. You saw how I improvised on replacing this capacitor to hold it up there where I needed it, so they could actually get it to stay where I wanted it in that tight position. Because that was a pain in the butt. They should have put the band the other way with the screw on the outside, and they had the screw on the inside of that band. I don't know why they did that, because it's right up against the wall. It's very hard to get hold of. Anyways, I hope this helps you. This is not all the problems you can have, but this is just a general problem why your fan doesn't turn. And there are other problems too. You really need to look at your units inside your furnaces and up in the attic if you have one to make sure that you're doing the right thing and you're inspecting everything. It can be just a quick fix, and yeah, some field guys may get lazy and just come out, hey, it's just a capacitor, I just gotta pop it out. Here you go. Here's $300 bill. Yeah. So I hope this helps somebody on your DI, do it yourself, and you understand a little bit more about HVAC and how dangerous it can be. Don't forget that 440 to 470 volts on that capacitor can kill an average human. Now, I've been shocked with a lot more and a lot of current before, many times, because I worked on power supplies in engineering, so I know how it feels to get shocked with a couple thousand volts or so, okay? And it ain't fun. Of course, I'm still alive. Thank you for watching. Thumbs up, and hit the like if you would, and tell your friends about my channel, about how I try to help other people do it themselves. I try to inform and educate and prepare people for what's to come, and what's coming is going to be a doozy, folks, so get ready for it.